right, in this video we're talking about interpolation and extrapolation. And so what this means is that we can use our line of best fit to make predictions about what is happening to the data in between the points we don't have. So we have the cost of raising a child who's 3 to 15, but only every 3 years. Well, what about when the child is 4, 5, 7, 8, 10, 11, etc.? So when we draw our line of best fit, we're going between two poles, the lower pole and the upper pole. So those are our end points of the data. And then in the middle, anything that we make a prediction on that's between those two, we call interpolation, and we can expect our guess to be reasonable. But if we look at values that are below our lowest pole or above our upper pole, well, that means we're trying to predict into the future without using any data, and extrapolation is often incorrect or invalid because it's not between our data points. So if we go to the cost of raising a child, use my line of best fit to estimate the cost of raising a child who is 10. So I have two ways that I can do this. One way is I can go to my line and I can look at 10 and go up, and then I can go over to estimate that value, and it looks to me like that value is going to be just below 14,000. So I could say that it's maybe 13,800. So that's using the line. And again, your line would be a better predictor because you've got a straight line. So I would say about $13,800. Or I could use my equation. So using y equals 13, what was my total? My slope, 1340 over 4 times x plus 9,000. Well, my x now is my age, my y is the cost. So I'm going to put in 1340 divide by 4 times my age, which is 10. And then I'm going to add 9,000, not 900. And we get 12,350. So I can see that something in my equation was wrong, and that's again because I'm not using a straight line, because now I've got that this value is actually below my mean, which does not make sense. So maybe this line is 10, 11, 12, yeah. So something in my slope is wrong. But again, if you use your incorrect value later, then that's okay. So we got 1340 over 4 times 10 plus 9,000 gave us a value of $13,325. And you could use either one, your line or your equation. Yeah. And hopefully your two answers would be about the same. And hopefully yours are because, again, straight line, ruler, better slope than mine, etc. All right, so why is it not valid to attempt to estimate the cost of raising a 30-year-old? Well, I can see that 30 is way beyond my line. So there's many reasons. So 30 is well beyond the data set. And another reason is that 30 is no longer a child. So this is the cost of raising a child. 30 is no longer a child. So those two things really go together, and that's why we would not use this data in this line.